Hi, everyone. Thank you so much for joining us for our session on capacity, quota, and stockout concepts and tips. My name is Lauren, and I'm the content manager for the Google Cloud community. We're really happy to have you here today and joining us. Just wanted to say before we kick it off with the content and hand it over to Stephen, our presenter for today, that questions are encouraged. So please feel free to add those into the YouTube chat, and we will be sure to get to them either in the chat or at the end of this session today live. So with that, we won't wait any further. We'll take it from there. Stephen, please introduce yourself and take it away.
Hello, my name is Stephen Tolan. I'll give a little more background in a moment, but for this session, we'll be covering this agenda items. So for this agenda item, for this session, the agenda items we'll be covering, we'll start with the background, which will set the stage as to why it's important to understand what capacity is in the cloud. We also will cover some concepts that will be key to understand, like capacity, quotas, and stockout. Also, we'll be covering some best practices to help out with the experience in the cloud as it relates to these concepts. Then we'll highlight some very common use cases to apply these concepts and best practices. And lastly, as Lauren mentioned, we'll end with some Q&A. So before we jump into things, I'd like to properly introduce myself. My name is Stephen Tolan, and I've been working in the cloud for over a decade. I have over 6 years of experience working in the tech and account manager role, which I am in today. And I've worked with many diverse customers, from Fortune 500 customers to startups, public and private sector, and even other verticals and industries as well. I am also both GCP certified in professional cloud architect and professional data engineer. And in my past life, I was a developer, big data architect, and also IT operations manager for large corporations. So let's start with the background. Have you ever heard the phrase, a failure to plan is a plan to fail? Well, that is very so much true when it comes to managing capacity in the cloud at scale. While the cloud does promise the idea of unlimited capacity, the reality is there's just lots of it and it's all shared. And there's only so much to go around at any given point in time, even though GCP is adding more all the time. And it's only fair that your neighbor doesn't consume everything. So capacity management is still very so much relevant in the cloud. Without a plan in place, you might find yourself in the awkward, not so great situation of not being able to get the resources you want when you need them. This can impact your application performance and leave your users with a poor experience that they won't forget anytime soon. So let's cover some concepts that are important to understand when dealing with capacity. GCP has zones, regions, multi-regions, and global concepts for GCP resources and services. Going from the top down, a zone is a deployment area of GCP resources within a region. This should also be considered as a single failure domain within a region. An example of a zone is something like U Essential 1A or U Essential 1B. These are noted with the letters at the end, hence A and B. A region is an independent geographical area that consists of zones. For example, in U Essential 1, is U Essential 1 for Iowa and North America. Also, Asia Southeast 1 for Singapore and Asia. Zones and regions are the logical abstractions of underlying physical resources provided in one or more many data centers. Multi-regions include more than one region. An example is a service that we have called Google Cloud Storage, where you actually can make a multi-region bucket and have objects stored in 2 regions for better performance or lower latency. Global is another concept we have, which can be any location. An example of this is our Cloud Content Delivery Network, or CDN, or even our Global Cloud Load Balancer. So as you can see, we kind of start from very narrow for the zones and then go out to regions, multi-regions, and global. Globally, we have 34 regions and 103 zones today that make up our Google Cloud platform. We are always expanding and adding more regions and zones for customers' needs all the time. Within each region, GCP has many services. For the sake of the session, we will focus on Compute Engine, as this service often comes up the most with customers in terms of capacity and quota. We always recommend discussing all your capacity needs early and often for all the GCP services you use to ensure you have the best experience in the cloud possible. So how does GCP define capacity and quota? Capacity is the availability of regional and zonal hardware resources that make up our GCP services required to run workloads. For example, for Compute Engine, this could be something like a VM family type that is made up of cores, RAMs, disk, and GPUs. Capacity is also shared across all of our customers. GCP defines quota as the upper bounds of resources that are set on a GCP project and service level. This can be physical or even an API. An example of physical is like launching something like a VM. An API example is something like maybe Compute Engine API to list all the instances. You're not actually launching or creating something, but you're simply creating an API call to list what's out there. By default, this is set to 1,500 requests per minute, but this can be raised through a quota increase request. If the real-time resources hits the quota, if the real-time resource usage hits the quota, any subsequent increase beyond this quota will be throttled. It's very beneficial to understand quota does not equal capacity. Just because you have quota granted, there's a possibility you might face something called a stockout, which we'll cover in a little bit of a moment. You can request to change a quota for a given resource. This can be an increase or also a decrease. You may find yourself in a need to increase your current quota to set it to new value. You can easily do this with most quotas directly in the GCP console. As you can see on the right-hand side, you just need to navigate to the IAM page in the console and look for quotas right there in the console. There, you can navigate to quotas for a specific service, API region, and request your quota increase directly there. Occasionally, you might have some quotas that need to be requested through support cases. So we strongly encourage you to check the quotas page for the GCP service that you're looking at and see if there is one. Once you do make a request, you can typically get a response of approval or denial within a few business days. Some are approved right away, but others may take a few business days depending upon the size and the resources that are being requested. For example, maybe a large request of say 10,000 cores of N2D VMs or something more or larger than that. We recommend working with your account team to ensure that, and if you don't have an account moving out team, you can definitely reach out to GCP sales to start this discussion. Also be aware that there are sometimes limits for certain quotas. This is usually not the case, but we strongly also recommend to check the product page for quotas and limits, just so that you're not surprised when trying to raise a quota and it can't be done. Even when you have quotas set, you might face something called Stockouts. This is when you request for resources that are not currently available on GCP. For Compute Engine, for example, the resource could be the VM family, the shape or type, or even maybe the type and amount and disk that you have. You will see a message like this here in the console or in your cloud logging. Often you just need to maybe wait some time and then retry the requested resource. We'll also cover some best practices to help prevent against this. We'll cover 4 key best practices to help you out the most here. Capacity planning is one of the most important best practices. On the right-hand side, you can create an example like this, or if you have a tech account manager like myself, they can share a template like this with you. This provides a way for you to collect the current and future capacity needs for your workloads that are running or will run on GCP. During the capacity planning phase, you will work with your Google account team to help you choose the right VM family and shape. This could be choosing a compute optimized instance like our C2s or C2Ds VMs for very heavily CPU workloads, or even our M1s or M2s for memory optimized workloads that are very memory heavy. You want to evaluate and address the capacity requirements at least 3 months in advance. This helps to understand the average versus peak usage and helps to understand if there are spike patterns, say something like a seasonal trap for your workloads, maybe a year-end close, product launches, or some other ongoing spike in your usage. Often we get capacity sooner than 3 months, but using this lead time provides the highest assurance that the capacity is available when you need it. Lastly, it's to set a scheduled checkpoint to talk about forecasting capacity needs on a quarterly basis. We know it's often hard to do this in advance, but starting this conversation early will greatly help your capacity experience in the cloud. Setting a schedule or cadence for this immensely helps with relieving stockouts, which we'll talk about in the upcoming slides. Another best practice is quota management. We start with planning. Part of the capacity planning process, you review and set quotas to match the capacity requirements needed. The quota plan to be raised should also include any planned spikes as part of this process. After you plan out what quotas you need, you want to raise them by submitting them. You can submit most of the quotas directly in the GCP console, as shown previously screenshot, by navigating to the IM page and selecting the quota you need. Some quotas that are raised will need some additional approvals. You will usually know within 1 to 2 business days if this is the case. If so, it's best to engage your Google account team on these. Raising these early with capacity planning will help with approvals of large requests. Say something like the previous example of 10,000 cores for something like N2Ds. Lastly, you want to monitor your quotas. There are solutions to help. We have solutions to help you monitor and alert when you're reaching a certain threshold for quota. This will notify you when you get close to your peak quota, which helps you to understand which quotas need to be raised before hitting a threshold. GCP also has a quota monitoring solution, which can be used for multiple GCP projects. This is helpful when you have workloads that span multiple GCP projects that leverage something called our shared VPC model. By proactive planning, submitting, and monitoring your quotas needed, this will greatly reduce the impact of hitting quota limits in production at critical times. Stockouts can happen when there is no capacity planning or quota management. Like shared before, a stockout message you will receive can be displayed in your console or in logging when the request resources are not currently available. This happens when this happens, simply just wait and try again. Often things will clear up after some time. This can be in waiting anywhere from 15 minutes to possibly maybe up to an hour, but greatly depends on the resources, region, and popularity. The cloud has capacity and it's very dynamic in terms of its use. You also want to leverage potentially different zones or regions. Having another zone or even a region you can deploy your workload in will increase the pool of resources you have access to. This helps lower the risk of a single point of failure when it comes to multiple zones available. This is also a highly available best practice. Consider a different VM family shape or family. This helps to diversify the resources for your workload that can be used and decouples your workload from the requirement of a specific VM family type or shape. This again increases the pool of resources you have access to. If you're using something called a managed instance group for autoscaling, consider changing the target distribution shape to balanced. This helps with scaling out workload to balance the VMs needed across one or more VM or zones if configured this way. You also can file a GCP Google Cloud support case to report issues and track major impacts when this occurs. This helps to track major stockouts that you can actually bring up with your Google account team for review. We also encourage our customers to work with the Google account team to discuss other options. Often there are times we can help you out when in a pinch. And the strongest best practice for stockouts is to engage your Google account team proactively in capacity planning. This is by far the best way to prevent stockouts on any cloud provider. Reservations is also another great best practice. Reservations allow customers to have a very high assurance in obtaining capacity for the critical workloads by reserving GCP resources. For example, in Compute Engine, you are able to reserve VMs in a specific zone. By default, a reservation is associated with one project, but you can also create a shared reservation where a resource can be shared across multiple projects. For example, like the shared VPC model like mentioned before. Resource reservations are billed at the same rate as resources running on and qualify for cuts, which are committed usage discounts. A VM can only use a reservation if it properly matches the exact property of the reservation, like region, zone, machine type, etc. Currently, reservations work for Compute Engine, Kubernetes Engine, and also Dataproc. We do have some new features for reservations that are currently under NDA, but are very helpful with proactive planning, especially for large traffic events like Black Friday and Cyber Monday. To learn more about this, we strongly encourage you to work with your Google account team or reach out to sales. So it might be very helpful to understand what reservations are for. They're typically for business critical workloads that require specific resources for a specific duration and any location or region. New workload, maybe even for a new workload launch or migration. To ensure the migration or launch is successful, a reservation can be placed to ensure that the resources are available when they are requested. This is also great for key traffic surge events like Black Friday, Cyber Monday, as mentioned before, or it can be something for like a new product launch or game launch or other launches that you might have upcoming as well. Also, you can use this to protect the minimum capacity of a managed instance group needed. For example, if you have an SLA or SLO that needs to be maintained, which requires a certain amount of compute resources being available. This also is a guaranteed capacity during instance recreation during rolling updates for GKE. What this means is that if you do an upgrade for GKE and it's adding and provisioning an extra node, you want to make sure that you have all the nodes available when you need during this upgrade in order to not impede the upgrade process itself. Using reservations is also a great way to do that as well. And as mentioned before, you can stack reservations with committed usage discounts. Then this is a great option if it's available for you. Committed usage discounts, or CUDs, as they're often referred to, are 1 to 3 year commitments on a given resource that allows you to have even steeper discounts on G3 resources, like say something like N2D VMs. On the right-hand side, you'll see a screenshot of filling out a reservation right in the console. You can see that there's some parameters you need to fill out, but once you fill it out and submit it and it's accepted, the reservation is available moments later. Now let's look at some common use cases. Organic growth is a workload that grows over time, but does not have large spikes. Capacity planning should still be going on. Capacity planning still should be happening on an ongoing basis. This can be for existing workloads that grow over time, or even new workloads that is migrating GCP but has a steady growth pattern. This could be a SaaS product that is not tied to a seasonality trend or just simply grows over time. Capacity planning and quota management are still important here. It is easier to plan these out because they have predictable growth patterns from past trends. Another kind of use case is the burst workloads, which represent a sudden increase in consumption. This is something normally like 10x the normal volume that you usually have. Capacity management is even more important for these type of workloads. To give you an idea, some examples are maybe onboarding a new SaaS customer that's quite large. It could be even a disaster recovery exercise, or maybe experimenting, or even proof of concepts. And lastly, also can be maybe some load testing or performance testing. Peak events like game launches, Black Friday or Cyber Monday for retail customers are a time you want to provide the smoothest experience for your customers. Here, capacity planning is very important to be early as possible. Usually customers have some sort of lead time with upcoming events, and working with GCP early and often helps you to ensure these workloads will go as smooth as possible. Premium support has something called Event Management Service offering for peak planned events. With this service, customer care partners with you to create a plan and provide guidance throughout the entire event. With the Event Management Service, or EMS as it's often referred to, your team is supported with the following tasks: preparing your system with key moments and heavy workloads, running disaster tests to proactively resolve any potential issues in advance before the event occurs, developing and implementing a faster path to resolution to reduce the impact of any other issues that might occur. This process needs roughly 1 to 3 months needs to be initiated 1 to 3 months before the start date. And the more time you have, the better you'll be prepared for your event. Also, after your event, your technical account manager, like me, will work with you to review the outcomes to make sure any recommendations can apply towards future events, because you always want to iterate and improve on the next event that might be coming up. To initiate an event manager service for an upcoming event, please contact your TAM if you have premium support. EMS, or Event Manager Service, is also available for purchase on other GCP support levels. Simply contact sales if interested. You can also learn more about peak events from a past Ask Me Anything event from this month of July, with the link is below in the slides. There's also an advanced version of the EMS offering. This includes something that's called a Resiliency Operations Review. We also do partner with you and bring in Google engineers to perform architecture reviews, traffic analysis, load testing, and even more. We also create a shared monitoring dashboard. We will join war rooms. And also, this is very beneficial to customers who need a lot more hand-holding for these type of events. This does come at an additional cost compared to our EMS offering, but simply reach out to us and we can have further discussions around this. So Lauren, I think we're back to you.
Yeah, thank you so much for that information. Very helpful. We have just a question coming in through the chat, but if you have any others, please feel free to add those in and we will address them now. So thank you, Stephen, for that awesome presentation. And before we move into the Q&A, just wanted to share a couple of high-level resources here. So at the top is the Google Cloud community where you can get plugged in, get your questions answered, and engage with Googlers and your peers, and find out about other events like this. The second link there is just to our architecture framework where you can find canonical best practices and documentation. And then lastly, we would love if you would join us for our next event with our technical account management team on September 22nd, where we'll be covering site reliability engineering fundamentals. And that link will be added into the chat now. So with that, we want to move forward to questions that we have received from the community first. So we'll start with this one. I'm trying to create a managed notebook. Although I have a quota increase, I haven't been able to create the notebook in any US regions and always get the same error. How much quota do I need so I can use this type of machine?
Okay, got it. Okay, so you can see here is an example where they're using a service that actually is using two GCP resources or two GCP services. One is notebooks, also known as Juniper notebooks, which actually runs on a VM, and also the GPUs. You'll need to make sure you have both quotas raised. In this case, it looks like they have the notebook raised, but it looks like they still need to raise the quota for the GPU. In this case, you'll need to raise the A100 GPU, which is noted in the error message that you see, GPUs A100 per project per region. And this will need to be done in the console, as you can, for specifically region US Central 1. GPU is often used for ML training, so after submitting the quota request, you should get a response shortly from GCP as well.
Awesome. All right. I have a TPU VM that I last used a couple months ago. When I try and start it now, I get the below response. Is there any way to access the data? All the docs I see about migrating VMs don't seem to apply to TPU VMs.
Okay, I think what's going on here. So it sounds like you are able to use the TPU or tensor processing unit, but after shutting it down, you're not able to relaunch it. This is a classic example of capacity being dynamic on the cloud. The message says actually there are no TPUs available in Asia East 1-C, and this means that zone C is in region Asia East 1. So simply for this one, you could probably just wait some time and try again, or you can try another zone if you want to stay in that region. The message actually contains URL that you want to check to see what other zones and regions the TPUs are in. Also, I think the access to data is referring to whether or not you can check other zones that have TPUs. The URL in the error message actually has all the information.
Cool, makes sense. I think we have just a few more that have been submitted through the community. So here is the next one. Is there a way to create alerts when your quota is about to reach its limit?
Actually, this is one of the best practices and commonly gets asked by customers. You most definitely can create alerting policies directly actually in Cloud Monitoring, obviously previously called Stackdriver, where you can create a quota alert to check every minute or so. This will create an alert that you'll see actually in the GCP console. You can also take it a step further to enhance this, which I've seen a lot of customers do, is by integrating Slack into the notification channels and alerts under Cloud Monitoring. Simply all this does is that when they'll check the quota, when it reaches a certain threshold, say 80% or 90% is reached, it will notify you in the console and then also post a message to Slack, like a Slack bot. This is very common for SREs and also infrastructure teams who own monitoring quotas.
Awesome. And we've just added a link into the chat as well to Cloud Monitoring for quick access there. Okay, is there a history or logs you can check for quotas and limit changes? I've been checking for quite some time and I can't see one. I need to know what quotas were changed on the project I'm currently handling for documentation.
Okay, all right, gotcha. This sounds actually like auditing code and changes. To my knowledge, there actually no easy way to do this out of the box for auditing these. But you actually, as a best practice, it's actually a security best practice, you can actually control who has access to change the quotas by limiting the IAM permissions to the user by following our security best practices of IAM, which is called least privilege. This is the concept of only granting the IAM permissions the person needed and nothing more. This is also commonly referred to as separation of duties. I know this is not common in agile startups, but is very common in large enterprise customers as well. One idea actually is to create a new GCP project that has the original default quotas, because in each project, when it's provisioned, actually gets a set of default quotas created. You can simply just compare maybe in 2 Chrome browsers or 2 Chrome tabs side by side, and actually just compare the quotas that are being used. So you don't need to check all of them, just check the ones that are being used and see what the difference is between the two. You can also use quota monitoring solution to actually export these on a regular basis, which is provided in one of the best practices for quota monitoring. This might be overkill for the case, but it definitely will allow you to basically export these historical changes to see exactly when they were done. It won't, you could probably enhance it to see who made these changes, but it'll basically have that historical changes for you to pinpoint when it might have happened, and then look at probably access logs to see who had access to the system at that time.
Great. Okay, thanks again for your questions in the chat. This is our last one before we will start to address those. I'm getting the following error while loading a file from Google Storage to BigQuery, but I can't find where I exceeded any of the limits. I'm using the PHP SDK load from storage method. In the quotas interface, it doesn't say that I exceeded anything, and we couldn't find any value that justifies reaching any quota. Any advice on troubleshooting or seeing where things are going wrong?
Okay, load from storage. Okay, I've seen this one before. So I know BigQuery has links on how to troubleshoot quotas, and sounds like actually this is the maximum number of table operations per day. I think this quota is set to 1,500 updates per day, and that sounds like actually maybe it's running into this limit in a 24-hour period. So you're actually only able to update a table 1,500 times in a 24-hour period. Probably sounds like you're doing that maybe on a more aggressive rate than that. So I would actually check the BigQuery quota troubleshooting page, which is actually very helpful for issues like this, because there's often a query you can run that actually give you more information about this issue, or even you can even possibly check cloud logging. Most likely you're hitting the maximum number of table operations per day, because the message says imports or queries appended per table. The appends per table is what's signaling me this is the issue for it.
Awesome. Thank you. And a link just to the troubleshooting BigQuery quotas has been added into the chat as well. Okay, so thank you for your questions. The first one we have here, is there a tool or service that can be used to monitor quota?
Yes, this was covered in one of the best practices. You can do this directly with cloud monitoring alerts and actually notify you when you're getting close to any peaks. You can also deploy the solution, which is in the link. We'll probably follow up on the post later. They actually can deploy a solution to actually export these out into a really cool Data Studio dashboard. So you get a nice, cool visualization. It usually keeps history track and trends like over 7 days. I think you can make it even extend it beyond that. So it's another way to actually have even more visibility and history trends beyond what we have in the console today.
Awesome. And then our last one here that we see, do you have any service or tool to optimize quota and capacity in Anthos on-prem VMware cluster?
Okay, so I've seen this come from customers. Because it's on-prem, we actually don't really have quotas that we set for on-prem resources. There are customers in this case sometimes typically look at deployments or pods within their cluster itself. So they actually have a monitoring tool they typically deploy on what resources are provisioned and how much is consumed versus actually requested. And we'll try to look up the links for that and put that post later. But that's one, because quotas, I've seen that being confused as being resource consumption on the Anthos cluster itself. And so we don't have quotas set in the console, but we do have ways to monitor those on a deployment level for container-wise.
Makes sense. And yes, just to reiterate, we will not only be sharing this recording, but also a recap post in the community, which a link to that is in the YouTube description, which will include all of the resources that we've covered and written answers to some of these questions. So for any that we don't get to or that come up later for you, you can add a comment to that article in the community and we'll be able to get back to you. Well, it looks like those are all of the questions that we've had for today. Thank you so much again, Stephen, for this presentation. And we hope we'll see you on the 22nd for our next session on SRE. But with that, did you have any final thoughts or recommendations before we close out?
No, just I love doing this. Hopefully we get to do some more videos, and hopefully I may be a recurring speaker for you all. Other than that, have a great rest of your day.
We'd love that, and we'll be in touch until next time in the community. Thanks, everyone.
Thanks,
Bye.
everybody. Bye.